In this video, we'll be studying about basic operation on discrete time signal. The first operation is time shifting and then time reversal, time scaling, amplitude scaling, addition and subtraction, and the last one is signal multiplication. All of these are done on discrete time signal, dt. Time shifting in discrete time signal. The time shifting x of n may delay or advance a signal in time. The first is the original signal. We are going to see an example of y of n is equal to x of n plus or minus 2. So this is the initial signal given, and here the values of n. N is equal to 0, n is equal to 1, n3 is equal to 2, and n4 is equal to 3. So these are the different values of n for the original signal. Here your x of n, the amplitude changes. For the original signal, the x of n is equal to 1. X of n is equal to 2. X of n is nothing but the amplitude. So for at n is equal to 3, the x of n, the amplitude is 3 again. So this is 1, 2, 3 and 3. So this is all about the original signal. Now we are going to advance in signal and then in the next delay in signal. So first we'll go with the first case, x n plus 2. When we go with this, now your n becomes minus 2. The value of n becomes minus 2. Now substitute this in n1, n2, n3 and n4. So now your new set of n1 is equal to 0 minus 2. n2 is equal to 1 minus 2. n3 is equal to 2. n4 is equal to 3 minus 2 minus 2. So this is the new set of n that is obtained. Here 0, 1, 2, 3 is the old set of n and minus 2 is brought from this value, that is from the question. X is equal to n plus 2. So now n becomes n equal to minus 2. So now this is the new set of n. Having this, you are going to plot. So for n is equal to 1, 2, 3. Please plot this 0, 1, minus 1 and minus 2. Now see the value or see the amplitude value. This is a new one, n1 at minus 2. Now what is the amplitude of n1 we saw? It was 1. What is the value of n2 we saw? It was 2. And what is the value of n3 at 3? n4 at 1, it is again 3. Now this is a new advanced shifted signal. Okay, it has been shifted towards left. So this is an advanced shift. Now let's see the delayed shift. The same thing. For a delayed shift, x is equal to n minus 2. Now here your n becomes plus 2. Now please substitute in the initial values of n. Now your n1 is equal to 0 plus 2. n2 is equal to 1 plus 2. n3 is equal to 2 plus 2. n4 is equal to 3 plus 2. I repeat. The initial n1, n2, n3 value is it's obtained from the original signal, and this plus 2 is what is required in the question asked. The new n1s are, the n values are 3, 4 and 5. Please plot them. 2, 3, 4, 5. 1, 2, 3, 4 and 5. Now see, the amplitude of n1 is 1. At 2. So don't mark here, mark here. This is 1. Here it becomes 2, 3 and this is again 3. So this is the new delayed signal. This is a new delayed signal. When x is equal to n plus 2, you get an advanced signal, and this is the delayed signal. This is all about time shifting in discrete time. I'll just repeat. This is the original signal x of n. You are asked to delay or shift by n plus 2 or n minus 2. So when you have, this is simple, so you can directly draw it. But when you have complicated problems, first write the value of n. n1, n2, n3, n4, and accordingly write the amplitude. Once the value of n and the amplitudes are written, start finding the value of nu n. So now the nu n for the case 1 will be 0. That is the initial one minus 2. 1 minus 2, 2 minus 2, and you get the new set of n's. You write that and draw the amplitude accordingly. Next operation is the time reversal in discrete time signal. The time reversal of a signal x of n can be obtained by folding the signal at n is equal to 0. This is the main thing, n is equal to 0. So first is the original signal, where you find n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. Here there are different amplitudes given. At n is equal to 0, it is 1. At n is equal to 1, it is 1.5. At n is equal to 2, the amplitude is 1 again. At 3, it is 1.5. So now when you are asked to do a time reversal, you keep this place as it is. Do not change this. If the signal is like this, do not change n is equal to 0, but bring the signal to the other direction. If something is like this, do not change the starting point, but change the rest of the signal to the other side. Having this in mind, please draw the resultant signal, that is time reversed signal. So here the amplitude will be same 1 when n is equal to 1. Next will be n is equal to minus 1. At minus 1, the amplitude was at 1.5. Then again at 2. Again at minus 2, the amplitude is 1. And then at minus 3, the amplitude is again at 1.5. So this is the time reversed signal. Time scaling in discrete time signal. For a signal x of n is scaled by x of a into n. So this a does everything. It's classified into two, downsampling and upsampling. As we have already seen the time scaling in a continuous time signal, they used to say compression and expansion. Downsampling is nothing but compression, upsampling is the expansion. Now here is an original signal given. Now here we see that the values of n are minus 3, minus 2, minus 1, 0, 1, 2, 3. And the amplitudes of all the values of n is 1. So let's see, n1 is equal to minus 3, take it as n2 is equal to minus 2, n3, n4, 1, 2, 3, 4, 5, 6, 7. So we can take till n7. It's minus 1, 0, 1, 2, 3. Now, the first thing we'll see what is downsampling, or what is a resultant of x into 2n. When I say 2n, this is the first case, x is equal to 2n. When we say 2n, here n becomes 1 by 2. So when n is equal to 1 by 2, your n1 becomes minus 3 into 1 by 2. That is minus 1.5. Next is n is equal to again minus 2. For n2 is equal to minus 2 into 1 by 2. This becomes minus 1. And n is equal to 1 by 2. n3 is equal to, the new n3 is equal to minus 1 into 1 by 2, that is minus 0.5. Similarly, n4 becomes 0 into 1 by 2, that is 0. n5, the new n5 becomes 0 into 1 into 1 by 2, 0.5, 2 into 1 by 2, 1, n7, the new n7 is 3 into 1 by 2, 1.5. Now let us write this, let us depict this in the picture. So it becomes 0, 1, 1.5, 1, 1.5. This way, minus 0.5, minus 1, minus 1.5. But the amplitude of all of these is the same 1. So 1, having 1 as the amplitude, your new downsampled signal is ready. This is the downsampled signal. The time scale alone has been changed. That we do not do any alteration to the amplitude. We only deal with time. The next is upsampling. Here we have considered x is equal to n by 2. When we say x is equal to n by 2, your n becomes 2. Now multiply this 2 with the values of the initial. That is n1, the original was minus 3, but the new n value is 2 into minus 3. That becomes minus 6. n2 original was minus 2. The new value is 2 into minus 2, minus 4. Again 2 into minus 1, 2 into 0, 2 into 1, 2 into 2. Again 2 into 3, 6. So having this, the new value of n is 0, 2, 4, 6. Minus 2, minus 4 and minus 6. The amplitude is the same for all. We do not do any changes to the amplitude. Here all the amplitudes are 1, so it's very easy. Otherwise there will be change in amplitude. Please check if it's for minus 6. So here it was minus 6. Check out for what value was it for minus 6. So the original was n1 minus 3. n1 minus 3. Check with the amplitude. It is 1. So please draw here. If it's minus 4, check what was the original value. That was minus 2. Minus 2. Amplitude is 1. Again draw. So this is how you have to do the time scaling operation in discrete time signal.